Faster Machine Learning Deployments, Why We Disabled GKE Image Streaming. Written by K. Alnajar, Machine Learning Ops Engineer. Why did we do this investigation? All of our machine learning services are hosted on Google Cloud using the Managed Kubernetes Platform, GKE. We saw that when the ML team was attempting to deploy a large image that had an additional lengthy setup, which relied on models saved to the image would fail to deploy and timeout due to the native progress deadline, which was set to timeout after 15 minutes. The logs showed that this was due to 7 to 8 minutes pulling the 25 gib and then 8+ minutes for setup. The setup took only 1 to 2 minutes on similar hardware that the ML engineer was working on, and this prompted the investigation to understand why this was happening. How the image streaming works. Looking at a great article by Replit, we believe Google is most likely using something similar to the SOSI snapshotter, as are Replit and AWS. The way it works is that it gets enough layers data to start the image, but then the rest of the data is accessed as needed. For ML images, this does not work so well, since they immediately need large amounts of data for setup when loading in the model. This is much slower than the traditional image pull and start, due to the number of hops required to get the data. Each file system operation must go from user space to kernel space to user space, fuse daemon, to kernel space, and finally back to user space. We see a very similar warning in the Google documentation as well. If your workloads read many files in an image during initialization, you might notice increased initialization times because of the latency added by the remote file reads. Testing image deployment without streaming. We created another node pool in the same cluster with the same machine type and GPU, and found that when we disabled the streaming, the overall time for the initial image pull decreased. The time was approximately the same at 7 to 8 minutes for pulling the image. However, the setup time decreased to 1 minute. This meant that our overall time dropped from the 16 minutes to 9 minutes on average. The savvy reader may be scratching their head here and wondering why the image streaming and the non-streaming took the same amount of time to pull the image. Excellent question. The reason for this is explained in the Google documentation. You might not notice the benefits of image streaming during the first pull of an eligible image. However, after image streaming caches the image, future image pulls on any cluster benefit from image streaming. Turning the image streaming off. This section might only be interesting to you if you are using Terraform to manage your GCP infrastructure. If not, feel free to skip it entirely. Realizing that many of our ML images would end up down this same path of loading large models or data up front, we decided to move away from using image streaming altogether. We toyed with the idea of separate node pools or clusters, but ended choosing the route with minimal overhead and maintenance. We manage our infrastructure as code using Terraform. According to documentation, turning off the image streaming should have been as simple as setting the configuration to false. After setting it to false and applying the in-place change, we check in the GCP console that our cluster and node pools showed us that the image streaming was disabled. Success, except it was not. We noticed that the deployments were still taking 16 minutes. Some investigation later, and it turns out that the change was not really applied, as confirmed by checking the new nodes spun up and seeing the image streaming label set to true. In addition, if we ran Terraform plan, we saw that it wanted to recreate the cluster and node pools entirely. Not good. It turns out this is due to the way the Terraform provider handles an empty return for the GCFS configuration versus the configuration returned from the resource. We will not dive into all the technicals here, but you can read the lengthier version in this GitHub issue, which is still open at the time of this writing. In order to actually get GCFS disabled, we needed to run the Google CLI and directly apply no-enable image streaming directly on the cluster and the node pools. After we ran this and checked the nodes, we saw that they were no longer getting the pesky streaming label. In combination with setting GCFS config to false on our cluster and node pools in Terraform, it also resolved the issue with the Terraform planning, and we get the very happy no changes output sought after. This video was created by Lazy to Read, based on an insightful article from the piccollage.com tech blog. Scan the QR code above to visit the original page, read more, or leave a comment. With Lazy to Read, you can easily turn any article into a video.